Every year, hundreds of retired aircraft arrive at massive recycling facilities, where nearly 90% of their parts will be given a second life.
Each aircraft is cataloged piece by piece, every component receiving a digital passport before dismantling begins.
The jet engines, worth millions each, are the first major components carefully detached from the aircraft.
Engines are transported to a separate refurbishment line, and many components inside can be reused in active aircraft.
The landing gear contains high-strength steel and titanium worth recovering. Every cut is precise to protect the metal. And the cut must be perfectly controlled. Aluminum alloy 7075 is dense and reactive to heat.
Each wing weighs over 8 tons, moved with millimeter precision toward the processing line.
Each fuselage section is measured precisely. Cuts must follow structural frames to preserve material integrity. Heavy-duty forklifts move fuselage sections to the secondary processing area.
All clear.
X-ray fluorescence scanners identify the exact alloy of each panel, indolence, critical for accurate recycling.
Plasma cutters reach 20,000 degrees Celsius, separating aluminum skin from internal frames in seconds.
Internal frames are cleaned of paint and bonding agents. Pure aluminum recovery requires zero contamination.
Shredded aluminum flows onto separation conveyors, and the next stage identifies and isolates pure metal.
Pure aluminum makes its journey to the smelter, where it will be reborn as new raw material.
Functional landing gears can be refurbished and returned to service, saving airlines enormous costs.
Avionics, including navigation computers and displays per pièce, are among the most valuable recovered components. Cutting the wings requires precision. A diamond blade saw slices through aluminum spars without overheating.
The hollow airframe now enters the main recycling hangar, Fortiuk, where the real heavy work begins. Cabin interiors are removed completely. Seats, panels, and carpets are sorted for reuse or material recovery.
Specialized hydraulic shears can apply over 200 tons of force, ideal for separating complex tail structures. Hydraulic shears slice through the aluminum skin like scissors, a process that took just 8 seconds for this section.
Skin panels are categorized by alloy grade. 2024 and 7075 aluminum dominate aircraft construction.
Cleaned frames now travel toward the industrial shredder, Riedelen, the next step in transformation. Each bin holds nearly 2 tons of pure aluminum, ready for the melting furnaces.
Eddy current technology uses alternating magnetic fields to launch aluminum away from non-metals.
The industrial shredder reduces aircraft frames into fragments smaller than a coin, at lire, in just seconds.
Magnetic separators remove all ferrous contamination, ensuring 99.9% pure aluminum output.
The detached section weighs nearly 5 tons ended, now ready for the next phase of dismantling. Once positioned, the wing will be sectioned into manageable pieces for the next processing stage.
Modern aircraft contain over 250 kilometers of wiring. The copper alone is worth thousands.
The induction furnace heats to over 700 degrees Celsius, anode, hot enough to melt even aerospace-grade aluminum. Aluminum fragments are charged into the furnace, melting almost instantly in the intense heat.
The dross, oxidized aluminum, is removed to recover pure metal underneath.
Every batch is tested by spectrometer, confirming exact aluminum purity before casting. The composition report confirms purity meets aerospace recycling standards.
Approved molten aluminum is poured at over 720 degrees, flowing toward the ingot molds.
The channel system delivers molten aluminum precisely to the continuous casting line. Each mold holds 25 kilograms of molten aluminum,
produced from recycled aircraft parts.
Cooling sprays solidify the ingots quickly Warren, locking the aluminum's structural properties.
Solidified ingots are removed, ready to be stamped with traceability codes.
Every ingot is stamped with batch and alloy codes for full traceability through its next life.
Titanium components, far more valuable than aluminum, receive specialized processing.
Each titanium blade is microscopically inspected, and many can be refurbished and returned to flight. CNC precision grinding restores titanium blades to original specifications, bypassing costly new manufacturing.
Coordinate measuring machines verify dimensions to within 5 micrometers. Aviation precision.
Non-reusable titanium is processed in vacuum arc furnaces, producing ultra-pure ingots.
The finished titanium ingot weighs 500 kilograms crest. Its market value exceeds $25,000. Inside the engine workshop, technicians peel back each layer of the turbine, uncovering valuable components.
High-pressure compressor blades, each costing thousands new, are gently extracted for testing.
Ultrasonic cleaning removes years of carbon deposits grown, restoring parts to like-new condition. Components emerge gleaming to ore. Every microscopic deposit removed by sonic energy. Fluorescent dye penetrant reveals cracks invisible to the naked eye. Failed parts are rejected immediately.
Plasma-sprayed ceramic coating renews thermal protection, extending the blade's lifespan by years.
Heat treatment at 950 degrees Celsius bonds the coating permanently to the blade structure.
Refurbished blades match the quality of new ones, at a fraction of the cost.
Refurbished components are reassembled with the precision of new engine production. Landing gear struts are stripped of old chrome, preparing them for fresh protective coating. Hard chrome plating restores strut surfaces to better-than-new corrosion resistance. Hydraulic actuators receive new seals and fluids, restoring full performance specifications. Each actuator must withstand 3,000 psi pressure, proving its airworthiness.
Aircraft wheels are separated from tires, both materials recovered independently.
Magnetic particle inspection ensures wheel hubs are free of any structural cracks. Approved wheels receive fresh aerospace-grade paint, ready for return to service. Refurbished wheels are mated with new tires and ready to ship to operating airlines.
Salvaged flight computers undergo full diagnostics. Many test perfectly after years of service.
Certified avionics return to the marketplace at 60% the cost of new equipment. Carbon fiber composites, once landfill material, are now systematically recycled for new uses. Pure carbon fibers emerge from pyrolysis, ready for use in new composite products.
Pyrolysis at 500 degrees separates carbon fibers from resin, recovering both materials cleanly. Aircraft tires are frozen with liquid nitrogen and then shattered, creating valuable rubber crumb.
Cabin plastics are recovered as pellets, used in new manufacturing applications worldwide.
Workers stir the molten metal to ensure consistency, essential for producing high-quality recycled aluminum.
Each certified blade returns to active service, saving over 90% of new manufacturing energy. Dynamic balancing ensures perfect rotation, critical for engine longevity and performance.
Inconel superalloys from hot engine sections are extremely valuable. Every gram is tracked.
High-strength aircraft steel klutcher, including 300 alloy platinum, is sorted and prepared for specialty steel mills.
Avionics circuit boards contain gold and silver, precious metals carefully recovered.
Chemical leaching separates gold and silver from base metals, concentrating precious materials.
Aircraft glass, multi-layered and tempered, requires specialized recycling techniques. Crushed aircraft glass becomes cullet, feedstock for new glass manufacturing. Insulation materials are bagged for specialized recycling corrosion. Even non-metal components find new life.
Modern aircraft recycling achieves over 95% material recovery. Minimal waste reaches disposal.
Every material stream is documented PON, providing full traceability to environmental authorities. Thousands of recovered aluminum ingots fill the warehouse, ready for global shipment.
A fully refurbished jet engine, saving over $5 million compared to new manufacturing.
The refurbished engine begins its journey to a customer airline, ready for another decade of flight.
Refurbished avionics ship globally to Little, each unit returning to active aviation service. High-value titanium ingots receive special handling, destined for medical and aerospace markets.
Each shipment is meticulously documented port to them, meeting strict international aviation recycling standards.
This massive facility processes over 200 aircraft each year, recovering 50,000 tons of valuable materials. Skilled workers make this transformation possible, combining engineering expertise with environmental purpose. Each day, more aircraft arrive. The cycle of recycling continues, building a more sustainable aviation industry. Aircraft aluminum becomes car parts, electronics, packaging, flying again in new forms. Recycled titanium even becomes medical implants, saving lives in hospitals worldwide.
This is the future of aviation cool, where every aircraft eventually becomes the next aircraft.
Final airworthiness certification favors. The engine is officially ready to return to the skies.
This is how millions of aircraft parts are recycled, saving our planet one aircraft at a time.
Each completed project represents skilled teamwork, saving resources and reducing waste.
200 aircraft processed yearly, 50,000 tons recovered, 95% recycling rate.
The final test, full power run-up, confirms the refurbished engine performs identically to a new one. A masterpiece of recycling, ready to power aircraft for another 30,000 flight hours.
Every output meets strict quality specifications. Recycled doesn't mean compromised.
The story comes full circle. Aircraft parts return to where they belong, the sky. As the day ends, thousands of tons of materials have been recovered Nikoti, ready for tomorrow's products.
The numbers tell the story. Dag, modern aircraft recycling is a billion-dollar industry that protects the environment.
Daily shipments of recycled materials leave the facility Halman, feeding industries around the world.